All right, outline what is meant by the principle of superposition of waves. I'm just going to read the mark scheme to you. When two waves meet, the resultant displacement is the, and then in little brackets, so you didn't have to say this, the vector sum of their individual displacements. And that means, of course, if you've got one displacement up and one displacement down that's bigger, right, it would be, you'd go this guy minus this guy, and you'd get like a little bit down, okay? So that's what they're looking for there. Obviously, I asked this question only once on the final because that'd be stupid to ask it twice. But notice that they're talking about the displacement, and they've got this whole thing about you can't talk about amplitude. So make sure you're talking about the displacements. Okay. Okay. So a red laser light is incident on a double slit with a separation of 0.35 millimeters. The double slit interference pattern is observed on a screen 2.4 millimeters from the slits. The distance between the successive maxima on the screen is 4.7 millimeters, right? So that's this distance here, right? So that's 4.7 times 10 to the minus third meters. Okay, so just be careful on this one about your milli is 10 to the minus 3, right? Okay, and then this is 0.35 times 10 to the minus third meters. Milli is minus third, okay, and then this is 2.4 meters, right? And then ultimately there's a formula here, right? The way I always remember it is I know that it's lambda is to d, right? This distance here is d, and lambda is the wavelength of these waves coming in, right? Okay, as s is to d. Okay, so there's two different geometries here. One is the ratio of the wavelength, which is small, to the slit separation, which is relative to the wavelength larger, right? And then there's the small separation of these divided by the large distance to the screen, right? And then, of course, if you're solving for S, this is the formula in the data packet. S is lambda d over d, right? Okay, so that is to the screen. Okay, that's the slit separation. And this is for the light. Although this could work with sound. You could do this with sound. You could have a couple holes in a wall and you'd get loud, soft, loud, soft, loud, soft there, right? Okay, so we just plug that in. You're going to plug in 4.7 times 10 to the minus third is equal to lambda that we don't know, right? Distance to the screen is 2.4 meters. And then the slit separation is 0.35 times 10 to the minus third meters, right? And you did this one as a quiz, I think, didn't you? Okay, so I'm going to go 4.7 e minus 3 times 0.35 e minus 3 divided by 2.4. And sure enough, I get the 6.85 times 10 to the minus 7th meters, which, by the way, would be 685 nanometers. We typically give wavelengths of light in nanometers. Now, spoiler alert, you've already done the quiz. You've successfully solved for lambda. I think on the final, I'm going to ask for this. I'm going to say, what's this? I won't tell you what that is, right? Holy switcheroo. D equals question mark, what could it be? And I'll tell you the wavelength of the light, and you figure it out from there, right? It's like, I think you can do that, though, right? Pretty basic stuff. Okay? Yeah? You excited to be part of that plan? I hope so.